Hello again, year 11. Today we are going to be finishing off the topic of exact trig values, and later on in the week I'm going to be giving you the opportunity to look at a non-calculator practice exam paper. So before we get started, a little quick activity to see how much you can remember about thirds. You will have used these in the previous lesson, and we are going to be using them again today. So, can you match the two equivalent expressions? Can you find the third written in questions 1 to 5 and which one it matches to, A to E? I would pause the video here, just give yourselves 2 minutes to think about the answers. So I'll very quickly go through the answers to these for you. The square root of 50. Well, you might recall the square root of 50 is the same as the square root of 2 times the square root of 25. Well, the square root of 25 is 5, so this would be 5 root 2, so 1 goes with C. Square root of 12 is not in its simplest form. This would be the same as the square root of 4 times the square root of 3, square root of 4 being 2, so this one can be written as 2 root 3. So 2 goes with D. Question 3. You might recall that you can multiply thirds. So the square root of 6 times the square root of 5. Yes, you just multiply the 6 and 5. So that is the square root of 30. So 3 is E. Question 4. Root 5 times 2 root 5. Well, you might recall if you take root 5 and times it by itself, that would be root 25 or 5. So when you square a root, you end up with the same number under the root. But this isn't root 5 times root 5, it's root 5 times 2 root 5. So root 5 times root 5 is 5, and times it by another 2 is 10. So 4 is A. Let's just make sure I did match 5 with B. 3 root 2 squared. Well, that means 3 root 2 times 3 root 2. 3 times 3 is 9. Root 2 times root 2 is 2. So this is 9 times 2, which is indeed 18. So 5 goes with B. How did you get on? So our last lesson on trig values. I've just put the table up again that we've seen from the last couple of lessons because we are going to be using all of these values or some of these values again. Last lesson you did some right angle trigonometry. These things don't have to always come up as a nice right angle trigonometry question. They could come up in various different guises. So I thought today we'd look at some slightly different examples, but using maths that we have seen perhaps before. I hope you've managed to print out the sheet, but the questions are quite short today if you've not been able to do so. So example number 1, what values of x, where x is between 0 and 360, satisfy cos x equals root 3 over 2? So this is a graphing question, but also involves you needing to know your trig values. Because we know the graph of cosine, I hope, looks like this. Between 0 and 360. It starts up at 1. It drops down to 0 at 90 degrees. By the time we get to 180, it's at -1. Back up to 0 at 270. And 360 is back at 1. So why have I drawn the graph? Well, we know that cos of x equals root 3 over 2, hopefully, from the ones that you know, is 30 degrees. That point there. However, you might recall when we did this topic earlier in the year, we saw there was multiple answers over 0 to 360 degrees. There's another answer here, And remember, we can get this from the symmetry of the graph. It's 30 degrees that way, so it's 30 degrees back from 360. So it's now 330 degrees. So just showing you, you can now do those sorts of questions for very specific angles without a calculator. Example 2 is a substitution. It says show that 12 sine 30 plus 9 root 3 tan 30 equals k, where k is an integer to be calculated. So what I'm going to do first is I'm going to write down at the side the ones that we are using, sine 30 and tan 30, and what they are equal to. And then we are just going to substitute those values in. So sine 30 is a half. You might recall tan 30 is one that I sometimes get wrong, but that is root 3 over 3. And all I'm going to do is now substitute these into the expression. If you wanted to make it a little bit easier, you could break this expression up into two parts. So let's do it that way. Let's do the 12 sine 30 first. Well, that is just 12 times a half, because sine 30 is a half. And 12 times a half is 6. That one was nice and straightforward. It's going to be a little trickier with the other one, because we've got 9 root 3 times root 3 over 3. So I'm going to do a little bit of cancelling first, because if you times something by 9 and then divide it by 3, that is just like timesing it by 3 instead. That's 9 divided by 3 is 3. So this is equivalent to 3 times root 3 times root 3. Hopefully we can recall from the starter that root 3 times root 3 is just 3. So this is the same as 3 times 3, which is 9. Okay, so that expression was for my 9 root 3 tan 30. And then we're just adding them together. So my answer is just going to be 6 plus 9, which is 15. And I'm confident about that answer because it's come out as an integer, and I was told the answer would be an integer. So my final example is example 3. It says calculate the area of the following triangle. Express your answer in the form k root p, where k and p are integers to be calculated. So what that means is the final answer to this is going to look like a number and the square root of a number. So something like 9 root 2. It's not going to probably be 9 root 2. I'm just speculating. That's what it might look like. So do you recall a bit of maths that we're going to need here? We're going to need a formula for the area of a triangle. And we're not talking about the base times height divided by 2. We are talking about the more complicated formula that is a half AB sine C. So the angle is my C. And these are my A's and B's. Okay, it doesn't matter which one you call A, which one you call B, it all works out the same. So you can quickly see I'm going to be using sine of 60. And I know that sine 60 is root 3 over 2. So all I'm going to do now is just substitute everything into my formula. There's going to be some surds in there, so we're going to be manipulating surds, and we'll see how we get on. So we have a half, and I'll punctuate it with times by signs. A is 8 root 3. We have B, which is 5 root 2. We have sine C, which is root 3 over 2. Now that doesn't look particularly nice, but you'll see there's a lot of simplifying that can be done. So ignore the surd parts for a minute and let's look at the whole number parts. We have an 8 times 5. Well, that's 40. Then we need to do a half of it. So that's 20. And then we need to do half of it again. So that is 10. So that has dealt with the half, the 8, the 5, and the other half from the root 3 over 2. We still have a times root 3. We still have a times root 2. And we still have a times root 3. But we know that a root 3 times a root 3 is a 3. And we still have the root 2. So 10 times 3 is 30. And we have root 2. So 30 root 2 units squared. That fits what the answer should look like because we were told it was a number, 30, and the root of another number, root 2. Just a post-production edit. I've written units squared. It should say centimetres squared. Okay, so there is a question sheet for you to try this time. All of these questions I've actually picked from previous exam questions. There's a few warm-up questions that are multiple choice. So just getting a feel for this topic sometimes just being as straightforward as a multiple choice. And then I've done some slightly harder questions so you can see some of the different scenarios that exact trig values have already been used for in exam-style questions. As always, check your answers at the end, and if you have any problems, you may contact me in the Ask the Teacher channel.